Hey everyone, welcome to part 6 of our discussion on learning. This time we're talking a bit more about the role of cognition in learning. Cognitive learning is the acquisition of new behaviors and information through observation and information rather than by direct experience. Cognitive learning can occur by observing events and others, and by using language to acquire information about events experienced by others. So up until now, we've been talking about acquiring learning through direct experience, but we know that there are ways that we can learn without direct experience. So you can observe events and others. So you might, watch someone walking down the street and see them stumble over, some raised sidewalk. You don't have to trip over that sidewalk yourself to learn that that's a place where you should watch your step, right? You see somebody else trip and you learn that you should be more careful. Likewise, you could watch somebody else performing some kind of a skill, and you could learn to imitate what they're doing. You can observe other people and learn to do what they do. Likewise, we can use language to impart information, right? So if I tell you that a particular type of fruit is poisonous, right? You don't have to become poisoned to learn that that fruit is something you should avoid. You also don't have to watch me eat that and get sick to learn to avoid it. If I describe something to you and say, hey, don't eat this, you can learn about that, right? Without any direct experience or without even any vicarious experience. You don't have to watch someone else do it. You can learn just from linguistically communicating that information. So let's talk a little bit about modeling and observational learning. So modeling is learning by observing and imitating others' behaviors or their actions. We certainly can't talk about this without discussing Albert Bandura and his famous Bobo doll study. You can read about this in your book and watch some videos on it. I think it does a great job explaining it, but we'll go over it briefly. Okay, let's talk a little bit about observational learning and modeling. Modeling is the process when we learn by observing and imitating others' behaviors or actions. And we can't talk about modeling without talking about our friend here, Albert Bandura, who believes that most human behavior is acquired through observational learning. And he's famous for his Bobo doll study. So as part of your assignment in Launchpad this week, you'll be watching things about the Bobo doll study and reading about Albert Bandura, but we'll talk about it briefly here. Basically, what Bandura showed through the Bobo doll study was that when children watched a video of an adult engaging in violent abusive behavior of this inflatable doll, the children were more likely to engage in very, very similar behaviors. In fact, performing even the same actions, straddling the doll and punching it, picking up a tool like a hammer and attacking the doll with it, kicking it across the room, these sorts of things. What's interesting about this is the children were likely to model the adults, but they weren't likely to model the adults if they saw the adults being punished for their interactions with the doll after they had performed these violent behaviors. So children not only learn to model behaviors from adults, but they learn what behaviors to model and which ones not to based on the consequences that other actors face. So as Bandura and others have pointed out, we engage in a lot of imitation and modeling behavior. We're more likely to imitate people who are rewarded for their behavior. So if we watch them have a good outcome for the thing they've done, are warm and nurturing. So if we have a good affinity for these people, if they're similar to us, so if they look like us or have the same social economic status or the same group, we're more likely to imitate them. If they have control or power over us, so a parent or a boss or something like that, we're more likely to imitate. Or if they have a higher social status, so if we look up to these people. You're more likely to imitate others on a task if, one, it's not too easy or too difficult. If it's right in the sort of sweet spot there. Things that are too easy, we don't need to imitate. And if things are too hard, we're probably not going to be able to imitate successfully. If you lack confidence in your own abilities, so if you're not sure how to behave in a situation or you're not sure you can handle it, you're more likely to just do what somebody else does. This is especially true if the situation is unfamiliar, so we don't really have the information necessary on how we ought to act. You might just model the behavior of others who seem like they're fitting in. Or if you've been rewarded for imitating the same behavior in the past, so if you've performed this behavior previously and it's gone well, you're more likely to continue to do that. So swinging back around here to vicarious learning, this is the idea that we can learn indirectly through others' actions and observing what happens to them, right? This leads to the concepts of vicarious reinforcement and vicarious punishment, meaning that basically we get a sense out of what will be punished and what will be reinforced by watching what others do and watching what happens. So our behaviors are modified not through direct reinforcement or direct punishment, but vicarious, right? Seeing what happens to other people, we think, oh, that didn't work out well for that person, I'm not going to carry that out. or that worked out really nicely, maybe I'll do the same thing that they did. So let's say you're visiting Washington, D.C., and you're trying to get around with the metro. And you walk down to the subway, you've never used the subway system in D.C. before, and you think, well, maybe I'll just, skip this whole payment thing and I'll just jump over the turnstile and jump onto a train. And let's say you see somebody in front of you do that, and one of the transit police comes over and, takes them aside and looks like they're in trouble. You think, oh, well, they got in trouble for jumping the turnstile. I'm not going to try that. But now you're left with a different problem, and you're not sure how to acquire a card or to put money on it or anything like that. So the machines are complicated, let's say. So maybe you stand back and you watch somebody else go and operate one of the machines, and you sort of watch what they do, and you say, oh, okay, that's the machine where they bought a new card. I can do the same thing. I'll just do what they do. So animals can do this as well, right? We're not the only species that's able to engage in observational learning. Your book highlights a really, really interesting example where monkeys were given basically 2 bins of corn. One of them was dyed pink and one of them was dyed blue. And one of these bins is sprayed with an agent that makes the food taste bitter. And the monkeys will develop a preference for the non-bitter tasting corn, right? Which makes sense. But even after the corn stops being sprayed with that bittering agent, the monkeys continue to prefer the color of food that was never made bitter. So if the pink food was bitter for this group of monkeys, they would prefer the blue food. What's really, really interesting is the next generation of monkeys who never came into contact with any sort of bitter food prefer the same food that everyone else does. So if everyone is eating the blue corn, the new young monkeys will also prefer to eat the blue corn. Let's talk very briefly about mirror neurons. Mirror neurons are basically a population of neurons that's activated when we watch others perform a task, and it's typically a similar population of neurons that we would use to perform the same task. So these reflect visual processing and mentally represent the actions of others. So, for example, we might see someone perform, a swing with a tennis racket or something like that. And if we're thinking about that and trying to imitate that, we will actually see similar activation in the parts of our brain that we would use to perform that action. It's theorized that our mirror neuron system may play a role in empathy, language, social cognition, and contribute to altruism and other social functioning type disorders. So autism and other social functioning type disorders. So the theory is that one of the reasons that we're able to empathize with other people is to a small degree we actually feel what we see. We don't actually feel it, but we feel sort of something adjacent to it as we imagine ourselves doing something similar. So observational learning isn't good or bad. We can learn to do pro-social things or antisocial things by modeling, right? So we may sort of observe pro-social behavior in others and model that behavior to have some sort of pro-social effects. We might see other people doing something positive and try to model that and do the same thing, but we can also have antisocial effects. So things like domestic violence, aggression, etc. can be learned via. And we'll sort of wrap up here by saying that there can be cognitive effects on even as simple of associative learning processes as classical conditioning, right? The pairing of the unconditional stimulus and the neutral stimulus is not all that matters. What you're thinking about can count as well. So one method that is used to sort of help alcoholics curb their drinking is to pair an alcoholic drink with a nausea-inducing pill, right? The thought being that if you come to associate the taste of alcohol with a very, very unpleasant sick state, you may have a lessened desire to consume alcohol. And this can help to some degree, but we're smart people, right? So we know that the only reason that we're getting sick is because there was something put into that drink that made me sick, and I've drank plenty of times before that and I didn't get sick. So we can, to some degree, with our cognition, overcome basic associative learning. Okay, that's it for cognition and learning. I will see you next time.